Hello everyone, so in this particular video we will be talking about image embedding task basically using Mediapipe obviously. So what is the idea? Basically you give any image, so this is one particular image, this is another image, and so what happens is if you give an image, it is going to be converted into vectors. Obviously there will be a model that will be converting into a vector. Same thing for this image, this is the vector. Okay, so for any image, so let's come over here. It does not matter what image you are giving. So there is a model over here, so there's a deep learning model. Okay, in this case we'll be using mobile net, but whatever, doesn't matter. So here you have an image, any image, if you give it, it is going to convert it into a vector. So vector of, let's say, n dimension. In our case it's going to be 1024 dimension vector. Okay, what is this vector? This vector is going to represent that image because it has the information whatever is contained in that image. Okay, so if you give in, this is I1, if you give I2, let's say there is no relationship between I1 and I2, it will also give you the same 1024 vector. Okay, 1024 dimension vector. Okay, it's going to give you a vector. And what to say, what happens is here also it is representing a vector. As I said, it is representing a vector and it has the information of that particular image. Okay, now each of these dimensions over here contains can mean anything, and we don't know because it totally depends on the data set. Okay, so let's say this can mean color, this can mean orientation, this can mean, let's say, perspective or transformation. Basically what I mean, this is a human or not, this is let's say there is water or there is no water, something like that, or how much amount of water, how much amount of human is there. So all that is basically, again, you don't know, it depends on the data set what each of these dimension is going to refer to. Okay, so basically image is given to a model. Okay, model over here, image is given to a model over here, and you get a vector. That is what is going to happen. Now how can we use this? We can say if two images, if the vector, say, okay, so for image 1, so let's say three images, I1, I2 and I3. So for that we get, let's say, vector 1, we get vector 2, and we get vector 3. If, let's say, I1 and I2 vector are similar, so how we are going to find similar? We are going to say it has high cosine similarity. Cosine similarity. Then we can say these two images are similar. Okay, that is how we're going to use it. So let's say you have a CBIR, content based image and video image retrieval, or let's say something, image search engine. I already have a video on my channel which basically explains how to create this, on similar concept, on this concept itself. So that video has over 10,000 views on this channel. You can go and see that particular video. Okay, basically how to create image search engine. Okay, that was the name of that particular video, if I remember correctly. Okay, so I had used a ResNet model over there. But whatever, ResNet model, mobile net model, the idea is the same. Convert image to vector and then do cosine similarity. Whatever, if the cosine similarity is high, it means that the images are similar. Okay, so that is the idea. The code example that I have taken is from here, but again I have modified it for simpler cases. The other things, again, not much required. Input, image processing, region of interest, all that. Okay, quantization, support scalar quantization for feature vectors. So there are two parameters, L2 normalization, normalize and quantize. I did L2 normalization. There was no difference basically. Okay, so the reason could be, the model internally does that, so we don't have to worry. We can directly go to the model. So mobile net v3 model, as I had said earlier. So in this case we will be using the small version of the model. Okay, so you can click on this and the model will download, but I'll be using Google Colab, so it will be downloaded over there. Here are some information. Okay, so let's go and look into the code. Again, you do simple Mediapipe installation. Okay, and then you write this particular line which is going to get the model. You can see mobile net v3 small.tf light. Okay, so once you hit shift and enter, I already have the model. Okay, so it doesn't matter, I have the model already. So I'll be showing you the images that I'm going to use, but let me do some basic imports. So you are importing CV2, again Google patch to show the image, but I'll be showing the image here only, so no need to show the image, and import path. Okay, after that, again, Mediapipe as MP, and then Mediapipe.tasks, and we are going to import Python because we are going to use Python for this particular example, and we are going to do a vision task. So Mediapipe.task.python import vision. Okay, again, base options, you need to give the model as a path. Here is the embedder.tf light over here, you can see. So I'm going to hit shift and enter over here. Options, same thing, just give this particular base options that you have over here. You have to just pass it over here, and there's nothing too technical over here. Just copy paste, copy paste, copy paste. Okay, so let's see over here what is the first person image. So I have taken 3 images. You can see it's a person. Okay, it's a person over here, a man that is folding hands and stuff. So you can see it's a person over here. Second image is that I have used over here is another person, but it's a little different. Okay, it's more of a squarish, and the person is smiling there. The person was not smiling here. The hand is missing. In that case, the hand was there. And the third image that I have taken is actually of a dog, my favorite animal, dog. So I have taken the image of a dog, which is again obviously different from a person. So if, let's say, this thing is working correctly, this model is working correctly, I should what I'm going to do is I'm going to first pass the 3 images. So this is first image, this is second image over here. I just copy pasted the path over here. How you can do, I have already said, you can go on the 3 dots and then copy path over here, and then you can go and paste it over here. Same thing for the other 2. Okay, so runtime is disconnected, but don't worry. After the 3 images are there, what you need to do, you need to find embedding result. That is, you need to find the embedding that is a vector of the particular image. So what you need to do is you need to pass in embedder.embed, and inside you need to pass first image. First image is where, this is the first image. Okay, same thing for the second embedding result, and same thing for the third embedding result. You just need to do embedder.embed and then pass the image here. After that, we will find the similarity. We are taking the first image, and then we are with respect to first image, we are trying to find the similarity with the second image and the third image. So obviously first image is person, second image is also person, so your similarity should be high. So the way you calculate similarity is you say similarity 1 2 is equals to vision dot image embedded dot cosine similarity. I hope you already know the idea of cosine similarity. So as I said, vectors will be created. So let's say this is the first vector, that is v1, and this is the first vector v2. So what we do, cosine similarity is vector 1 dot vector 2, okay, divided by mod of vector 1 into mod of vector 2, right? This is the cosine similarity. This is basically cos theta. This is cos theta, right? So this is the cosine similarity that we want. Okay, this again will range from -1 to 1. Why -1 to 1? Because cos always ranges from -1 to 1. Okay, I hope you remember this particular concept. So what are we going to do? Again, similarity of 1 2, that is 1 with 2, that is image person 1 with person 2. We are going to say vision dot embedder image embedded dot cosine similarity, and here we are going to here we are going to pass the first embedder here, first embedding result, that is the vector. The way we pass the vector is, again, you can see over here, I'll just copy it over here. Okay, I'll just copy it over here just to show you what it is. I'll go over here and let me just paste it over here. Okay, so first embedding result, you can see there is some embeddings over here. Okay, so what you need to do is embeddings. If you just do the embeddings, you basically get the embedding. So you take 0th of that, and again it will ask you to do the embedding stuff. So you're going to say embeddings, embeddings, and then you can hit shift and enter. Okay, not embeddings, I think embedding is the right one. Yeah, you can see the embedding is there. And if you print the shape of this, so if you say shape, I think it is 1024. Yes, 1024. So basically you see it's a vector, right? Vector of size 1024. So after that, what you did, you found the similarity for 1 and 2, and you have gotten it over here. Same story for 1 and 3, that is between person 1 and dog image. You pass the first embedding result, and then you again pass the third embedding result, and then you found it to be similarity 1 1 3. Then what you did, you basically run this particular cell, and you got this the first similarity, that is similarity between person 1 and person 2, to be 0.09. Not very good, but okay. And this one is 0.05. Okay, which means that we need similarity to be as high as possible, in the positive area. So obviously we can say that this particular image has similarity 1 2 is greater than similarity 1 3, which means this particular image, that is image 1, is closer to image 2 than image 3, which is actually correct, because image 1 is of a person and image 2 is also of a person, and image 3 is of a dog, and two people are closer to each other in the image rather than a dog. So I hope you understood and you like the video. If you like, please like and subscribe. Thank you very much, and bye.